Imagine trying to send a letter without a postal system. Chaos. That's what it would be like without network models. Network models bring order to the way computers talk to each other. They create a set of rules. These rules ensure that data travels smoothly across networks. One of these models is the OSI model. It's like the blueprint of network communication. The OSI model stands for Open Systems Interconnection. It's a conceptual framework. It helps us understand how networks work. The model divides the complex process of data transmission into 7 distinct layers. Each layer has a specific job. Think of it like a factory production line. Each station has a role in assembling the final product. Why are network models important? They provide a common language for network professionals. This makes it easier to design, troubleshoot, and secure networks. Without these models, networks would be unreliable. They would be difficult to manage. Just like you need a common language to understand someone, computers need a common language to talk to each other. That's where the OSI model comes in. It's the Rosetta Stone of computer network. The OSI model has 7 layers. Each layer performs specific functions. Let's start at the top and work our way down. Layer 7, application layer. This is where you, the user, interact with the network. When you open a web browser, send an email, or stream a video, you're using applications that operate at this layer, Layer 6, presentation layer. This layer ensures that data is presentable. Think of it as the gift wrapping layer. It makes sure data from one system can be understood by another. It handles tasks like encryption and data compression. Layer 5, session layer. This layer is the network's manager. It sets up, coordinates, and terminates conversations between computers. Imagine you're making a phone call. This layer is responsible for dialing the number, keeping the call connected, and hanging up when you're done. Layer 4, transport layer. This layer ensures that data arrives reliably and in order. It's like a reliable delivery service. It divides data into packets and adds error-checking information. Layer 3, network layer. This layer is responsible for routing data packets across networks. Think of it as the GPS of the network world. It uses IP addresses to figure out the best path for data to travel. Layer 2, data link layer. This layer controls the physical transmission of data over a single network. It handles error detection and correction at the local level. Layer 1, physical layer. This is the hardware layer. It includes cables, connectors, and network interface cards, NICs. It's the foundation upon which all other layers are built. The TCP/IP model is another network model. It's more commonly used in practice. The TCP/IP model has 4 layers. These layers roughly correspond to the 7 layers of the OSI model. Application layer in TCP/IP combines the application, presentation, and session layers of the OSI model. Transport layer in TCP/IP matches the transport layer of the OSI model. Internet layer in TCP/IP is equivalent to the network layer of the OSI model. Network access layer in TCP/IP combines the data link and physical layers of the OSI model. The OSI model is more theoretical. The TCP/IP model is more practical. Both models are useful for understanding how networks operate. They help us to troubleshoot problems and design efficient networks. So why is it important to understand the OSI model? Here are a few reasons. Troubleshooting network issues. The OSI model helps technicians isolate problems. By examining each layer systematically, they can identify the source of the issue. Network security measures are implemented at various OSI layers. Understanding these layers helps in building robust security policies. Network design. The OSI model provides a framework for designing and implementing efficient and scalable networks. In conclusion, the OSI model is a valuable tool for anyone working with networks. It's the language of network communication. By understanding its layers and how they interact, we can build better, faster, and more secure networks.